Good morning, dear students. My name is Ferhan Mazher, and today is 6th December 2021. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. It's Cambridge O Levels Physics. Today, we have set our hearts to solve an MCQ paper, and we have selected October-November 2009 paper 1. This MCQ paper has 40 MCQs. And the time allowed for this is 1 hour. And so let's start today's paper. Let me show you the first. Let me show you the paper. Okay. So this is October-November 2009, paper 1. So let's go to the first question. So we have the first question, and it says vernier calipers read to 1/10 of a millimeter. Which reading shows this precision? If you look at the options, all the options, the unit used is centimeter. They have not shown the units in millimeter. So 1/10 of a millimeter means 1/10 of a millimeter. So let me convert this, show you how this can be done. Okay. So 1/10 of a millimeter means 0.1 millimeter. If you convert the millimeter into centimeter, you have to divide it with the 10. So you got 0.01 centimeter. So in centimeters, 1/10 millimeter means 0.01 centimeter. So after the decimal, there are 2 decimal places. So we will check that which option has after the decimal 2 decimal places. So let's see. So let's check. Let's check. After the decimal, 2 decimal places is in this option. So this will be your, I think this will be your answer. Question number 1, I think B is the right answer. After the decimal, there are 2 decimal places, and the unit is centimeter. So this is the one which is correct to up to 1/10 of a millimeter. So let's check. B is the right option, sir. Our answer is right. Question number 2 coming up on your screen. Which list contains only scalar quantities? Scalar quantities are those quantities which have only magnitude. Acceleration, displacement, mass. Acceleration, displacement, they both are vector. Acceleration, distance, speed. Acceleration is a vector quantity. Displacement, mass, velocity. Displacement is a vector quantity. Velocity is a vector quantity. Distance, mass, speed. This list has only scalar quantities. So I think D is the right answer. So I think D is the right answer, sir. Question number 2, D is the right answer. So let's check. Question number 2, D is the right answer. Okay. Okay, here we go. We have the question number 3. So let's reduce the size a little bit. Okay. Which speed time graph shows an object moving with non-uniform acceleration? So here we have 4 options. All of them are basically speed time graphs. And in the speed time graph, you know, the gradient of the speed time graph shows the acceleration. If you want a non-uniform acceleration, the gradient of the graph should be changing. If the acceleration is non-uniform, that means that the gradient of the graph should be changing. So I'm looking for that graph which is not a straight line but a curve. So I think C is the right option. Here the graph is a curve, so gradient is changing, which means non-uniform acceleration. So I think question number 3, C is the right choice. Question number 3, C is the right choice, sir. Okay, so we have question number 4 coming up on your screen. Let's increase the size so you can see the whole question. He says the graph shows the speed of a car as it moves from rest. What is the average speed of the car during the first 3 seconds? So it's a speed time graph. On the y-axis, we have speed. On the x-axis, we have time. So I want to know what's the average speed. I should first of all calculate how much is the distance traveled in the 3 seconds, and then I will divide that distance traveled with the time taken, and that will give me the average speed. Now, the total distance traveled I can find by calculating this area under the speed time graph, and it's in the shape of a triangle. So you can find the area of this triangle, 1/2 base into height. The base is 3, the height is 12. So just put those values and you will be able to find out the average speed by dividing the distance traveled with the time taken. So let me go to the solution. I've done this question. So we have question number 2 showing up on your screen. It says the distance will be equal to the area under the speed time graph, and that will be 1/2 into the base into the height, and that will be 1/2 into 3 into 12. So it will be 18 meters. So the distance traveled is 18 meters. The time taken is 3 seconds. So average speed we can find out by using the formula. Average speed is equal to distance divided by time, and that will be 18 meters divided by 3 seconds, and that will be 6 meters per second. So the average speed will be the total distance traveled divided by total time, and it's 6 meters per second. So let's check. Do we have that option? Yeah. So I think B is the right choice. Question number 4, B looks the right option. Question number 4, B looks the right option, sir. Question number 4, B is the right option. Okay. The next question. A tractor pulls a trailer at a constant speed. Important thing is that the speed is constant. The tractor exerts a forward force of 1600 Newton on the trailer. What is the force exerted by the trailer on the tractor? Because it's moving with the constant speed, so the backward and forward force, they are equal to each other. So if the tractor has applied a 1600 Newton force on the trailer will apply the force in whose magnitude will be the same, and the force applied by the trailer on the tractor will be 1600 Newton, and in the backward direction. I think B is the right choice. Question number 5, I think B is the right choice. Question number 5, B is the right choice. Okay, so we have question number 6 is coming up on your screen. He says a turntable rotates at constant speed. A coin is placed on the turntable at the P. The friction force between the coin and the turntable keeps the coin in the same position on the turntable. In which direction does the friction force X? You see, when you move in a circle, this coin will be experiencing a friction force, which will be providing the centripetal force, and that friction force or the centripetal force will be always directed towards the center of this circle in which this turntable is rotating. So that direction should be A. Question number 6, I think A is the right choice. Question number 6, A is the right choice. Okay, so here we go. The next question coming up on your screen is, he says, a room measures 4 meters by 3 meters by 2 meters. The density of the air in this room is 1.3 kg per meter cube. What is the mass of air in the room? So we can calculate the volume of that air, and we can also, let me feel this up. That's question number 7. So first of all, I will find the volume of that air. That air is in that room. So whatever is the volume of that room, same is the volume of the air. So we will have length into width into height, and that will be 4 into 3 into 2. That will be 24 meter cube. The density of the air is 1.3 kg per meter cube. So mass is question. So, density is equal to mass divided by volume. So mass will be equal to density multiplied volume. Density is 24, volume is 1.3. So 24 multiply 1.3. That will be 31.2 kg, which is approximately 31 kg. So let's check. 31 kg is the answer, we think. 31 kg. I think D is the right choice. Question number 7, I think D is the right choice. Question number 7, D is the right choice. Okay. Here we go. The stability of a bus is tested by tilting it on a ramp. The diagram shows a bus that is just about to topple over. Where is the center of the mass of the bus? The bus shown in the diagram is about to topple, okay? So it's tilting and it's about to topple. So where is the center of the mass? So from all these points, the possible locations of the center of gravity, we will draw the line of action of the weight. We will draw the line of action of the weight. And that point will be the center of gravity, which is still inside this base and it's about to, in which the line of action of weight is about to go out of this base. The base is this. Okay, so let me show you my work, and this is question number 8. Okay, so here we go. So with these red lines, I have tried to show the line of action of the weight. A cannot be the answer because here the line of action of the weight is outside the base. So if this is the center of gravity, the bus has been already toppled. This cannot also be the answer because you see the line of action of the weight is outside the base. Here on the C, it's the line of action of the weight is still inside the base, but it is about to go out of the base. And the D cannot be the answer because it's perfectly inside the base. So there are no chances that if this is the center of gravity, the line of action of the weight is about to go out of the base. So I think C is a point where the center of gravity can be. And in this, the line of action of the weight is still inside the base, but it is about to go out. So I think C looks the best option to me. Question number 8, I think C is the right answer. We think C is the answer. So let's check. Question number 8, C is the answer. Question number 8, C is the right answer. Okay, so let's go to the next question. So here we have another question. Let me reduce the size. You can see the whole thing. Okay. A load L is suspended from 2 springs that are in parallel. The extension of each spring is X. The springs are then arranged to hang vertically one below the other. What is the new arrangement? In this new arrangement, what is the total extension of the 2 springs? Here, when you hung this load L, that load will be divided equally on these 2 springs. So this spring here is experiencing a load of L by 2. And this spring on the left and the right side is also experiencing a load of L by 2. So due to the L by 2 load, the extension is X. Now in this, in each individual spring, the extension is X. So the springs are then arranged to hang vertically as one below the other. Now this complete load is exerted on this spring. This complete load is also exerted on this spring. So now before, in this case, this individual spring was experiencing L by 2 load, but now it's experiencing full load. So the extension produced will also become double. So there will be an extension of 2x in this spring, and there will be an extension of 2x in this spring. So the total is, extension in both the springs will be 2x in this, 2x in this, 4x. So the total extension will be 4x. Because this load is fully experienced by this spring, this load is also fully experienced by this spring. So there will be an extension of 2x in this and an extension of 2x in this. So the total extension will be 4x. So I think D is the right choice. Question number 9, D looks the right answer, sir. Yes, D is the right answer. Okay, so let's move to the next part, and here we have the next part. A long tube full of mercury is inverted in a small dish of mercury. The mercury level in the tube falls, leaving a vacuum at the top. When the atmospheric pressure falls, which length decreases? You see, from R to Q, from the R to Q, this length of the mercury represents the atmospheric pressure. If the atmospheric pressure will decrease, the length RQ will also decrease, or QR. So which length decreases with the decrease in the atmospheric pressure? The length from R to Q basically represents the how much is the atmospheric pressure. If the atmospheric pressure will drop, this length will also decrease. So QR, C is the right choice. C, question number 10, C looks the right option, sir. Yes, that's true. Okay, so we have the next question coming up on your screen. It says some gas is trapped in a large syringe by a piston. The atmospheric pressure is 100 kilopascal. And the pressure gauge indicates that the gas pressure is 200 kilopascal above atmospheric pressure. The piston moves outward and the volume of the gas trapped gas doubles. The temperature remains constant. What is the new gas pressure? Okay, so the pressure of the gas in this position is 200 kilopascal above the atmospheric pressure, and atmospheric pressure is 100 kilopascal. So the total pressure of the gas is basically 100 plus 200. It will be 3 kilopascal. And then he says, I doubled the volume and the temperature is kept constant. So we can apply the formula P1 V1 is equals to P2 V2. Okay, so here we go. We have this formula because gas, the temperature is constant. And so the product of the pressure and the volume remains constant. So P1 V1 is equals to P2 V2. P1 is 300 kilopascal. The pressure of that gas was 200 more than the atmospheric pressure. Atmospheric pressure was 100. So the total pressure of the gas will be 300 kilopascal. Its volume, suppose, was V. Then they double the volume. They make it 2V. So what will be the new pressure? P2 is the question. So P2 will be equal to 300 kilopascal divided by 2, and that will be 150 kilopascal. It means that the pressure of the gas will be 150 kilopascal. So let's check 150 kilopascal. Do we have this answer? 150 kilo. What's the new pressure? New gas pressure? That's 150 kilopascal. So B looks the right answer. Question number 11, B is the right answer, sir. The diagram shows energy transfer through a machine. So here we have input energy, then we have machine. The machine will give you useful output energy and there will be wasted energy. What is the efficiency of the machine? The efficiency of the machine will be useful output energy divided by the total input energy. So I think which formula is the good one? Useful output energy divided by the input energy. Yeah, this B looks the best option, sir. Question number 12, I think B is the right answer. Yes, question 11 was B answer. Question number 12 was B answer. A man weighs 600 Newton. He runs up a staircase of total height 4 meters in 3 seconds. How much useful power is needed to do this? You see, the man is going vertically upward by the staircase. So the total vertical height he will gain will be 4 meters in 3 seconds. So the work done will be weight multiply the vertical height you gain. And then if you divide it with the time, you will get the power. So they are asking how much useful power is needed to do this. It will be the weight of the man multiply the vertical height divided by the time taken. So let me show you. Power is equals to work divided by time. So the power will be equals to weight into vertical height divided by time. So 600 multiply 4 divided by 3, and that will be 2400. And I think 2400 divided by 3. So when you divide 2400 with 3, you get 800 watt. So the power produced will be 800 watt. Let's check. Yeah, B is the right option. Question number 13, B is the right answer. Yes, question number 13, B is the right answer. And the diagram shows 4 cans in a cool room. They are painted as shown. One pair is filled with hot water and left to cool down. The other pair is filled with cold water and placed after near infrared heater. So the hot water in the black can cool more quickly than the hot water in the white can. The cold water in the black can heats up more quickly than the cold water in the white can. Which row shows the reason for this? Batimeter black color, when it has hot water in the black color will be the best means emitter of the infrared radiation. So better absorber will be also black color, because the black color will be very good absorber as well. It's also very good emitter and it's also very good absorber, the black color. So which shows the reason for this? So better emitter of infrared red, that will be the black, and better absorber of the infrared, that will still be black. So I think question number 14A is the right choice. Question number 14, let's check. I don't know. Question number 14A is the right answer, sir. To calibrate a thermometer without using another thermometer, fixed points are required. Which statement is correct? Any temperature can be used as a fixed point. No, both a lower fixed point and an upper fixed point are required. Yes, that's true. And but only a lower fixed point is required. No, only an upper fixed point is required. That's wrong. Both a lower fixed point and an upper fixed point are required. I think 5 is the right answer. 15, 5 is the right option. B is the right option. Question number 15, B is the right option, sir. Question number 16, a block of metal has a mass of 2 kg. The specific heat capacity is 800 joules per kg per degree centigrade. The block is supplied with the 2400 joules of energy. What is the rise in the temperature? Here, because the rise in the temperature is involved, so we will use the formula heat is equal to mc delta theta, where delta theta means the change in the temperature, and that is the question. Heat is equals to mc delta theta. The supplied heat is 2400 joules. The mass is 2 kg. The specific heat capacity is 800 joules per kg per degree centigrade. Delta theta means the change in the temperature is the question. So delta theta will be equals to 2400 divided by 1600. So the delta theta will be 1.5 degree centigrade. 1.5 degree centigrade. So 1.5 degrees centigrade, 1.5 degrees centigrade. I think question number 16C is the right option. Question number 16, I think C is the right option. C is the right option, sir. Now, a quantity of gas is trapped in a container by a piston exerting a force F. The temperature of the gas is raised while F remains unchanged. Which statement is correct? We have increased the temperature and the gas expands. That's true. The gas molecules get larger. That is wrong. The piston remains in the same place. No, that is not right. The speed of the molecules decreases. That's not right. And usually temperature is increasing. So which statement is correct? The temperature of the gas is raised while F remains unchanged. Which statement is correct? A gas expands, yes. The molecules get larger, that is wrong. The piston remains the same position, no. So the gas expands, I think, is the right answer. Question number 7. Question number 17. A looks the right option. G, sir. A is the right option. And the diagram shows the cross section through a rainwater puddle formed in a shallow depression in a road surface. So here you have that road surface, and here we have a puddle, and the water is collected here. Over a period of time, the air temperature, wind speed, and wind direction all remain constant. What happens to the rate of evaporation of water from the puddle? You see, as the puddle from the puddle, the water will evaporate. The volume of the water will become less and less. So the level of the water in the puddle will go down, because from the top the puddle is wide, but as you go down, the puddle becomes less and less wide. So the surface area of the liquid will decrease as the water will evaporate. The level of the water in the puddle will go down. So the surface area will become smaller. So when the surface area will become smaller, the rate of evaporation of the water from the puddle will also decrease. A is the best option. It decreases because the surface area decreases. That's true. As the level of the water will go down, the top surface of the water, which will be exposed, will become small, because the puddle is in the shape of a cone. So it decreases because the surface area decreases. I think A is the right option, sir. Question number 18. Question number 18, A is the right option. So we have the next question. The diagram shows a ball floating in a tank of water. So in this direction, the waves are going from left to right. The ball is here. When these waves will reach here, the ball will move up and down, up and down, up and down. It will not go with the water waves. It will go up and it will go down. That will be the mean position of water. Which diagram shows the movement of the ball as the wave passes? It should be going up and down. So I think D looks the best option to me. Question number 19. D is the right option, sir. Okay, so the next question is, he says the diagram shows a ray of light from one point on a lamp striking a plane mirror. The image of the point on the lamp formed by the mirror is, the image will be here somewhere, where this line will be prolonged and will cut, and this line will be produce this mirror and then goes back. So here the two lines will intersect. Here you will see the image. The image formed, because this is a plane mirror, the image formed will be virtual. So the image will be formed at the P and this will be virtual, I think. Question number 20, B is the right answer. Question number 20, B is the right option, sir. So we have the question number 21. The diagram shows the passage of a ray of light through a triangular glass prism. What is the critical angle? To see when the light is entering from a dense medium into the rare medium, the angle of incidence in the dense medium will be called critical angle. If the angle of refraction in the air will be 90 degree, in the rare medium will be 90 degree. So clearly you can see here the light is traveling in the dense medium, it comes out into the rare medium, and the light has moved on the surface of the prism. The angle formed here is 90 degree. So this angle of incidence in the dense medium will be known as critical angle. So this angle D is the critical angle, because its angle of refraction in the rare medium is of 90 degree. So D is basically the critical angle. The angle of incidence in the dense medium, whose angle of refraction in the rare medium is of 90 degree, that is known as critical angle. So D is the critical angle. So let's check D. Question number 19, D is the right choice. Sorry, question number 21. We are working on question number 21. So let's check question number 21. D is the right choice. Question number 21, D is the right choice. The critical angle will be the angle D. Okay, so let's move to. An object is placed in front of a diverging lens as shown on the scale diagram. The principal focus F is marked on each side of the lens. What is the position of the image formed by the lens? So if you want to locate the position of the image, because this is a diverging lens, so I will start from the head of the object, a line which will be parallel to the principal axis. And then I will join this point and the focal point, and the light will be diverged from here. The second ray, I will start from the head of the object and it will pass through the optical center undeviated, where these two lines will intersect, and that will be the image. Let me show you from the diagram, it will be much easier. Okay, so we have done this question. Okay, so we are done with question number 20 also. Okay. So we have drawn this red line, which is parallel to the principal axis. Then from here, this point and this point F will be joined. And then you can see the light will be diverged. So then I will start a ray from the head of the object and it will pass through the optical center undeviated. So where this red and the blue line intersect each other, there you will find the image. So B, at the point B, you will be able to find, at the point B, you will be able to find the image. So this is that image. Okay. B is the choice. So I think B is the right answer. The diagram shows the trace produced on a cathode ray oscilloscope by a sound. Which trace is produced when both the loudness and the pitch of the sound are increased? So you can see that here on the display, we have 1.5 complete wave. And amplitude from the mean position to the top point or from the mean position to the bottom point, the amplitude is just 1 square. So now what you have done, you have increased the loudness and the pitch of the sound. So if you will, when we trace produce when both the loudness and the pitch are of the sound are increased. Okay, so pitch is increased, the loudness is increased. So for the loudness to increase, you know, the amplitude should become larger, more than 1. Here the amplitude, this is the mean position, the amplitude is just 1. So the amplitude should become larger and the time period should decrease. On the display, the frequency should be more. On the display, there will be more waves showing. So which rays is produced when both the loudness and the pitch of the sound are increased? If you increase the loudness, the amplitude will become larger. Instead of just going 1 step upward, now it will go more than 1 step. And because on the same trace, there will be more number of waves. On the same screen, there will be more number of waves. For example, I think it looks the best option. You see the amplitude has increased, and on the same display now 2.5. Now approximately 2.5 is showing, whereas yesterday we did a question in that. So before you can see we have 1.5. Now you have how much? 1 to approximately 2.5. 2.5 waves are showing. So more waves, more amplitudes. This means louder and higher pitch. So it looks to me that D is the right option. Question number 23. D is the question number 23. D is the right option, sir. Which rod describes the ease with which iron or steel can be magnetized and demagnetized? Iron is very easy to magnetize and it's also very easily demagnetized. So for if the iron is the choice, then both the terms should be easy. Steel, on the other hand, is difficult to magnetize it and it's difficult to demagnetize it. Steel becomes a permanent magnet. Okay, so C looks the best option, sir. Question number 24, C looks the right answer. Question number 24, C is the right answer. A negatively charged rod is brought close to an isolated T-shaped piece of metal. Initially, the metal is uncharged. Which diagram shows the induced charges on the metal? So you have brought a negatively charged rod near. Obviously, from here, the electrons will go backward, and on these sides, the negative charges will appear, and on this tip, the positive charge will appear. I think A is the best option. Question number 25, A is the right option, sir. Very good. Let's go to the next question. The circuit diagram shows three resistors in parallel with the battery. What is the effective resistance of these three resistors? Because they all are connected in series. So in parallel to each other, sorry, I said series, they are connected in parallel to each other. So very easily I can find out the equivalent resistance. 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. And then you can calculate it, the equivalent resistance. Very easy question. Okay. Now you can see here is that case, these three resistors, they are connected in parallel to each other. I can find the equivalent resistance. 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. And you will have 1 by R equivalent will be equal to 1 by 4 plus 1 by 2 plus 1. And if you make their denominator same, so you will have 1 by R equivalent will be 2 by 8 plus 4 by 8 plus 8 by 8. So now I can write the single denominator and the numerator will be added up because the denominator is the same. So 2 plus 4 will be 6, 6 plus 8 will be 14. So 1 by R equivalent is equals to 14 divided by 8. And 14 divided by 8. So R cross multiply R equivalent will be 8 divided by 14, and that will be 0.571 ohm. 0.571 ohm. 0.571 ohm. 0.57. So question number 26, A looks the best option. Question number 26, A is the option. Ohm's law states that the current in a conductor is proportional to the potential difference across it, provided that a certain quantity remains constant. What is the quantity? That is the temperature. The physical quantity should not change. Normally we say temperature should not change. The length, the pressure, the temperatures. I think C is the option. So D choice, thickness. I think that the temperature should not change. Question number 27, C is the right choice. Yes, question number 27, C is the right choice. Okay, so we have question number 28. It says two resistors of 6 ohm and 12 ohm are arranged in parallel. A potential difference is connected across the terminals X and Y. The current in the 6 ohm resistor is 4 amperes. So you can see here, I know the resistance in this branch, I know the current flowing through this branch, so I can find out the voltage drop here. You know, the V is equals to IR, V is equals to IR. So 4 ampere multiplied 6 ohm, that will be 24 ohm. And sorry, the voltage drop will be V is equals to IR. So 4 into 6, that will be 24 volt. 24 volt. So whatever is the voltage drop in this branch, because this branch is parallel to this branch. So if you have 24-volt voltage drop here, so same voltage drop will be here. So if I know the voltage drop here and I know the resistance of this point, I can find the current. So then once I know this current, I know the current in this branch, I will add them up, and that will be the total current coming from the battery. Okay. Question number? Yeah. So here you see, I know this 6 ohm and this 4 ampere current. I can find the voltage drop in this branch. V is equals to IR. So V will be equal to 4 into 6, and that will be 24 volt. So the voltage drop here will be 24 volt. Same voltage drop will be here. So it will be 12. V is equals to IR. So V is equal to IR. So I is the basic question. So 24 is equals to I into 12. So the I will be equals to 24 divided by 12. And that will be 2 ampere. So it will be 2 ampere. So I know the current flowing through this branch is 2 ampere. 4 ampere current is flowing in this branch. 2 ampere current is flowing in this branch. So from here, both the currents will be together. So you will have 6 ampere plus 2 ampere, and that will be 6 ampere. 4 ampere plus 2 ampere, and it will be 6 ampere. So let's check 6 ampere. 6 ampere. Do we have that choice? Yeah. Question number 28. I think B is the 6 ampere. Okay. The diagram shows the standard main plug. Okay. So this plug has earth wire, it has live wire, and it has neutral wire. So here is a 3-cord cable, and this is the cord grip, which keeps the cord. It do not let the cord come out or broken. And what are the correct colors of the wires? So the neutral wire will be blue, the earth wire will be green and the yellow, and the live wire is brown. Okay. So the neutral wire will be blue and the earth wire will be green and the yellow, and the live wire should be brown. I think B looks the best option to me. Question number 29. I think B is the right option. Question number 29, I think B is the option. Question number 29, B is the right option. Which costs the most if operated from the same main supply? A option is 5,000-watt electric cooker used for 1 minute. A 1,000-watt electric fire used for 10 minutes. A 500-watt electric iron used for 1 hour. And 100-watt lamp used for 1 day. So we are looking for most if operated from the same, which will cost most. Okay. So we can find these the values used, and that is done by calculating the electric energy. You know, So you know energy is equals to power by time. So whatever device will take more electric energy, that has its cost will be more. Running that machine will cost more. He says energy is equals to power multiplied time. The power should be in the kilowatts and the time should be in hours. So 5,000 divided by 1,000 to convert it to kilowatts, multiply 1 divided by 60, and you will get the final answer 0.0833 kilometer kilowatt hour. Sorry, kilometer I said kilowatt hour. The B option is 1,000 divided by 1,000 into 10 divided by 60, and the answer will be 0.167 kilowatt hour. E3 will be 500 divided by 1,000 multiply 1, and that will be 0.5 kilowatt hour. And the fourth one is 100 divided by 1,000 multiplied 24, and that will be 2.4 kilowatt hour. 22.4 kilowatt hour. So let's get question number 30. I think question number 30. It will be most expensive. Each diagram shows, let me check the answer. Question number 30, D is the answer. So I have not checked the answer. So question number 30, D is the right option, sir. Each diagram shows a cross section through two parallel conductors, each carrying an electric current. In the conductor on the left, the current is into the page, and on the right, it is out of the page. Which diagram shows the direction of the forces on the two conductors? Okay, because both the conductors, the current has opposite directions. Both these parallel conductors, the current in them is in the opposite direction. So when the current is in the opposite direction, they are the conductors, they are supposed to repel each other. They are supposed to repel. If the direction of the current is opposite, then they will be repelling each other. So I think C is the best option. They should be repelling each other. Question number 31. Question number 31, C is the right option. Question number 31, C is the right option. This is the option we have taken. You have studied this law that the parallel conductors, if the direction of the current flowing in them is same, they will repel each other. A simple model of a DC motor is made. By mistake, the split ring commutator is left out. The coil can turn, but is always connected to the battery in the same way. The coil starts in the horizontal plane. What happens to the coil when the circuit is switched on? It does not move at all. No, it moves upward out of the magnetic field. It turns to the vertical position and eventually stops there. It turns to the vertical position and then comes back to the horizontal position. So what happens to the coil when the circuit is switched on? It does not move at all. We check question number 32. Question number 32. C is the right option. Question number 32, C is the right option. It turns to the vertical position and eventually stops there. The coil starts in the horizontal position. It rotates. It happens to the coil when the circuit is switched on. It does not move at all. It moves upward out of the magnetic field. It turns to the vertical position and eventually stops there. Yes, that's true. When it will become vertical, the coil will become vertical. The coil will be stuck there. It cannot go far in the next phase, and neither it can go back. It will start doing this. That's why we use the commutator. So C is the right option, sir. A magnet is pushed horizontally towards a coil of wire, inducing an EMF of the coil. In which direction does the induced EMF makes the coil move? The EMF induced will take the coil away from this magnet. So away from the magnet, yes. Towards the magnet, no. Downward, no. Upward, no. Because this magnet is approaching, so this coil will try to move away from it. That is the rule. That's the law they are following. The coil, the induced current, and due to that induced current, the coil will become a magnet, and it will try to move away from this magnet. So I think A is the choice. Question number 33. A is the right answer, sir. Question number 33. Here it says the graph shows the output of an alternating generator. The coil in the generator rotates 20 times in 1 second. In 1 second, it rotates 20 times. So the time period will be, you can see here, from here I can tell the time period to complete one wave, it took 0.05 seconds. So it says, which graph shows the output when the coil rotates 10 times in 1 second? So if it rotates 10 times, so now you can see if it will rotate 10 times in 1 second, this time period will reduce. This time period to complete the wave will reduce. See here, to complete a wave, you have to take 0.05 seconds. Now, in 1 second, it's going 10 times faster. So during the same duration, there will be the time period should decrease, and the amplitude should also increase, I think. Which graph shows the output when the coil rotates 10 times in 1 second? So it's saying 10 times in 1 second. Okay. So the coil rotates 20 times in 1 second. Here it was rotating 20 times in 1 second. Now he's saying 10 times in 1 second. So basically the speed of rotation has decreased. So when the speed of rotation will decrease, the amplitude will decrease and the time period will increase. Okay, so time period should increase. Yeah, this is the option. The time period has increased and the amplitude has decreased. So D looks the best option. D. Question number 34, D is the right option. Why is a transformer used to connect a generator in a power station to a long distance transmission line to decrease the voltage and decrease the current? To decrease the voltage and increase the current? No. To increase the voltage and decrease the current? Yes. That's the reason. To increase the voltage and decrease the current, because when you reduce the current by increasing the voltage, the power loss in the transmission lines will decrease. The power loss in the transmission lines is given by the formula P is equal to I square R. So when you decrease the I value, the power loss also decreases. So I think C is the best wording. Question number 35. C is the right answer, sir. The diagram is a circuit designed to switch on a lamp when it gets dark. So which component is used as the sensor at X? Here we should use the light dependent resistor LDR, because when it will be dark, its resistance will increase. So the voltage drop here will increase. So that's why the lamp will start giving out the light. So I should use here the LDR, light dependent resistor. And the correct symbol for the LDR is option C. Question number 36, C is the right option. Question number 36, C is the right option, sir. Okay, so we have the next question, and that next question is question number 37. A thermistor is connected in a circuit with a 6-volt battery, a 300 ohm, a 3000 ohm resistor, and a voltmeter as shown. The graph shows how the resistance of the thermistor varies with the temperature. So here in this axis, we have here the temperature, and here we have the resistance. And you can see here, what is the temperature of the thermistor when the voltmeter reads 2 volt? This is like a potential divider. This is V out, and it's from R2. So I can show you that question. Okay, so you know the V out is equals to R2 divided by R1 plus R2 into the voltage of the battery. The V out is 2 volt equals to R2. We don't know, that is X, and the R1 is 3000 ohm plus X, and into the 6 voltage of the battery. And bring this here, so it will be 2 by 6, so it will be 1 by 3. So you will have 1 by 3 equals to X divided by 3000 plus X, so cross multiplied. So you will have 3X equals to 3000 plus X. And then bring this X to this side, it will subtract, you will have 3X minus X, and that will be 2X equals to 3000, and X will be equals to 3000 divided by 2, and that will be 1500. So the value of the R2 is 1500. So I can use the graph, you know, that graph. I know that R2 is 1500. Now I know the R2 is 1500. So from here, this is 1500. I will go to the graph. And here, when it cuts the graph, I will check what's the value of the X, and that is 60. So the temperature is 60 degrees. So I think C is the right option. So question number 37. C looks the best option to me. Let's check. Question number 37. C is the right answer. Question number 37. C is the right answer, sir. The activity of a radioactive source is measured over a period of time. The graph shows the decay curve. Why is the curve not smooth? The reason is radiation is the random process. Background radiation has not been subtracted. No, radioactive decay is a random process. Yes, that's the perfect answer. The half-life is not constant. The temperature is changing. The basic correct answer is that radioactive is a random process. Question number 38, B is the right option. Yes, question 38, B is the right option, sir. Okay, the next question coming up on your screen is, he says, a radioactive isotope has a half-life of 6,000 years. How much time passes before the rate of emission from a sample of this isotope falls to 1 by 16 of its original value? 1 by 16, and the life is 6,000. So at the start, suppose it will be L naught, the sample will be L naught. After one half-life, it will become N by 2. After another half-life, it will become N by 4. Another half-life, it will become N by 8. And another half-life, it will become N divided by 16. So how many half-lives? 1, 2, count the gaps, okay? 1, 2, 3, 4. 4 half-lives have passed. So one half-life is 6,000 years. So 4 has passed, so it will be 4 into 6,000, and that will be 24,000 years. So 24,000 years. 24,000 years. I think C looks the best option. Question number 39. Question number 39. C looks the best option, sir. So we have the next question, and the next question is this one. He says a nuclide of strontium is represented by the symbol SR3888. What does the nucleus contains? We know I can break down it, and let me show you. Okay, question number 40 is coming up on your screen. He says strontium 3888. So the proton numbers are 38, electrons will be also 38, and the number of neutrons will be 88 minus 38, and that will be 50. 50. Number of neutrons will be 50. So look at the statements of this question. He says 38 electrons, that's true, and 50 neutrons. It looks good. Option A looks good. Let me check my paperwork. 38 and 50. 38 and 50. A looks the best option too. Question number 40, A looks the best option. Question number 40, D is the right option. Oh my, we're wrong. What's wrong? 38 electrons and 50 neutrons. He says, oh, what does the nucleus contains? Look at this word. This is very important. It says, what does the nucleus contain? The nucleus does not host electrons. The nucleus does not have electrons. So I think D is the best option. 38 protons and 50 neutrons. The question is, what is inside the nucleus? We don't have electrons in the nucleus. So 38 protons and 50 neutrons. 38 protons and 50 neutrons. These electrons are not in the nucleus. They are outside the nucleus. So let's check the answer. D is the right option. So I think this is over. So my dear students, we are done with this paper. This was October-November 2009 paper. It's an MCQ paper. Paper 1, we call it. I hope that you have understood this paper. And I have tried my best to explain the concepts. If you have taken out time and you are watching this video, I am very grateful to you. And I will request you that if you think that this video is helpful, and it can help you, it can help your class fellows, your seniors, your juniors, and don't hesitate to share the link of this video onto your Facebook account and into your Instagram accounts. It will be a great appreciation for me, for my work. So once again, thank you very much. It's a pleasure to teach you all. Thank you very much. Have a good day. God bless you all.